Eric's Guitar Amplifier Repair, helping musicians to perform better. Welcome to Eric's Guitar Amplifier Repair here in California. My name is Eric. Most recently, I viewed a video of Gary Moore performing at a Montreal festival in 2001. He was performing a song called The Prophet. The guitar he was performing with was a Gibson Les Paul standard double cutaway, 24 frets, with a DiMarzio pickup in the bridge position. The flame maple top was a chevron type, and it was heavily flamed. I was so fascinated by this guitar that I've never seen before in the Gibson lineup that I purchased the guitar. Now, I didn't purchase Gary Moore's guitar, obviously, but I did purchase the identical guitar manufactured in 2001. I, as an engineer technician, am asking you out there, those luthiers that are knowledgeable, or engineer technicians that are also historically knowledgeable, and even Gibson, those that may be working at Gibson, to tell me what this guitar is. For an example, who was the design engineer? Why did they design this particular guitar? And what was really, in general, the purpose? It is an unusual guitar compared to a regular Les Paul standard, and I'm very curious about this guitar. I will, at this point, explore the guitar. I can tell you at this time that it is a chambered guitar. That is, there are no holes drilled into it. It's actually chambered and then sandwiched together. So I'm very fascinated to find out what all of you guys out there know, or gals, and please leave that in the comment section or contact me through email, so on and so forth. Let's begin to explore what this guitar looks like. Let's begin. And here is the guitar. A beautiful double cutaway, nice flame maple top. You can see a standard badge over the truss rod cover. These are the 490T type pickups installed. We will replace the bridge pickup with a Jeff Beck type by Seymour Duncan. I will rewire the circuit to the 50 style, that's my preference. And the rest is up to you out there. Tell me, what is this guitar? I don't know what the purpose of this guitar is, why they manufactured this at this time. I heard rumors that this was to compete with Paul Reed Smith, in particular the Santana model, but I have no way to verify this, and I see no data on the World Wide Web. Nice back there. It's a really pretty guitar. We have removed the neck pickup. Looking at the pickup cavity, we can see some writing, what appears to be a T and an M, and a D and a B. Just as I suspected, we have a full neck tinion. You can see a big glob of tight bond. So those of you out there that debate tight bond as a good adhesive as opposed to animal glue type adhesives, you can comment about that below. I am curious what your thoughts are out there. But tight bond, big old glob of tight bond. Animal glues have been used in instrument making for many centuries, for a very, very long time. We know how it behaves. Tight bond is a newer adhesive used in instrument making. We don't know how it will behave over time. So it'll be interesting to see what the outcome is as far as that types of adhesives. Looking at the bridge cavity, we see LPS and what appears to be a 2, LPS2. The factory bridge pickup has been removed. This is the 498T, and we are reading 14.5 kilo ohms on this pickup. Looking at the Seymour Duncan pickup here, we are reading 16.85 kilo ohms, or 17 kilo ohms. So we're looking at the cavity area of where we're going to work on replacing the bridge pickup. We're looking at the circuit. Looking at the wood section here, we have an H and what looks like a 4. We're looking at the maple cap here, and I will get an endoscope and we'll look inside here. This has all been cut out. This is like a semi-hollow, not unlike what I assume Brian May's guitar. It's probably identical, if not very similar, as far as the design, the body design, the guitar design, for having a sort of a semi-hollow body. So it's very interesting. I didn't realize that this is what I had in my possession. This is an interesting design by Gibson. But back to the circuit, I'm going to wire the bridge pickup and this whole circuit into a 50s style. Everything here looks like it's 50s like style. What we have that's different is we have this capacitor here, what appears to be a 22 microfarad. In this design, we have this lug here with a jumper wire to this lug here. So what we're going to do is very simple. We're going to remove this wire from here to here. We're going to take our capacitor, our paper and oil capacitor is what I've chosen for this guitar, and we'll attach the one lead of the capacitor at the center lug, and then from the center lug to this lug number 3 here, and that'll go from here to here, and that'll be the 50s wiring. So I will show you that. I won't be able to show you the actual installation point by point. It'll be before and after, and this is just difficult for me to work in here like this. I'll purchase a more sophisticated camera system in the future, but for now, this is what we're going to do. So we're looking at the circuit. It has been revised to the 50s style. We have to acknowledge that we have the tone. The center lug will be not attached to ground. You need to attach the center lug to ground on the tone. This wire here goes to this lug here. If you wire this and you find that the tone portion of the circuit is not working, that's where your problem lies. It'll be predominantly having the center lug on the tone not attached to ground. Again, if you have this wire attached here, as in the original circuit, and the tone is not working, then you can attach it here. We're looking at a very simple circuit pickup wiring. In the Seymour Duncan pickup scheme, we have black going as the hot side, and the green and the shielding ground soldered together, and that would go to ground. In this case, I've used these jumpers to flip the polarity. That is, hot is going to ground and ground is going to the hot part of the circuit. Why? This puts this in the out of phase when the toggle switch is placed in the center position. You can check and see if this is something that you like without being committed to soldering and then desoldering and resoldering to see if this is a sound that you would like to try out. In this case, I've decided yes to go ahead and do the reverse polarity at the wiring section of the pickup as opposed to flipping the magnet. Looking at the body of the guitar, I notice that it appears that we have a large chamber here, a large chamber. We have a small chamber that is visible just by looking at this part of the guitar cavity. So we have a chamber here, and I suspect there's a chamber here. That would indicate to me that we have a large piece of wood here, and I suspect that there is a nick through joint attached to this large piece of wood, this rectangular piece of wood here. So we will verify that with an endoscope, and we'll look at that in the next segment. We have the endoscope inside the cavity of the guitar, and we're going to explore to see if we truly have a full cavity. So you can see the outer top section of the guitar. Moving along. Yes, you can see the very end of the route here. Let me see if this will go any further. No, it looks like we are at the end here. Let's see what we find as we withdraw the endoscope. Interesting. So it appears that we do truly have a full cavity routed out of this 2001 Gibson double cutaway. I will show in the next segment what that looks like in a 3D model. So let's take a look at that now. So we're looking at the circuit. It has been revised by me. This is now a 50s style type circuit. We removed the 0.022 microfarad capacitor. This is the volume potentiometer. Center lug, we have a 0.022 microfarad paper and oil over-engineered capacitor here. This is rated at 600 volts. Going from the center lug from the volume to the third lug of the tone potentiometer. We had a jumper wire from here to here that has been clipped out, and now we have a 50 style circuit. Eric's Guitar Amplifier Repair, helping musicians to perform better.